Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Guwahati University of Science and Technology. Today we will take lecture number 27 of the subject of visual programming, in which we will discuss the graphical device interface in C#.NET. Dear students, graphical device interface is the set of the libraries which is used to draw different objects on the form. These libraries are the set of different classes are used to designs and develops the graphical applications in the C#.NET. This is the introductory lectures in which we will discuss the GDI classes and the functions here. So we will provide you some basic examples as well of the GDI classes and functions. This is the discussion agenda which contains the topics of the rendering graphical device graphical data with the GDI. So all the graphical data will be rendered with the GDI plus and how we can use certain classes and their functions to render the data. GDI plus is the next generation graphical device interface which is mostly used in the web application as well as with the Windows applications. Then we will discuss the GDI namespaces, that means the important libraries in the GDI. Then we have the functions of the GDI, that are the different methods used in the GDI. Then we have the point F, the types. Point F is in fact a class which takes two different parameters of the floating point values. Then we will discuss the example of string drawing in the GDI, that how we can draw the strings in the GDI. Then we have the obtaining a graphical object out of the paint event handlers. So here we will discuss how we can use the paint event handler to draw the GDI, that is the outside of the class. Then we have the GDI plus coordinate systems here. So we have three different coordinate systems of the GDI. So we will discuss these topics in the GDI plus coordinate systems. Now rendering the graphics data with the GDI plus. GDI, which means that graphical device interface, is the collection of multiple classes which are used to render different graphics, which includes the stylized text and the image data. So we can also draw the styles text, that is the strings, and also we can draw the images, and also we can perform certain processing on the images as well. And all these things can be drawn onto this form surface area. That means that we can draw this stylized text and the image data on the form. So for this purpose, we require the Windows applications here. We cannot perform the GDI on simple console applications, but when the console application creates the forms, then we can perform the GDI programming on the console as well. So here we will take a high-level look at the numerous drawings related namespaces. When there the namespaces are different libraries. And also we will examine the role of the paint event, which is very much important for the GUI programming. In the paint event, in fact, paint or draw the different components of the GUI on the form. And the almighty graphics objects means that different objects which are in fact the instance of the graphical device interface classes. So we can use all these graphics objects to draw different sort of the components on the form. Now GDI covers how to manipulate colors, fonts, geometrical shapes and graphical image onto the form. So we can use the color classes, then the font classes and geometrical shapes classes like line classes, curve class, rectangle class, or any other class, and also the graphical images, and all these components can be drawn on the form surface. Now, it's very much important to understand the GDI namespaces. GDI namespaces are different libraries which we import on the top of the program. For example, a simple library is using system. So we write that library on the top of the form or on the top of the coding so that we can use their functions in our program. The GDI has these 5 important libraries. First namespace or a library is called the system.drawing. Now this is a very important GDI plus namespace. GDI plus means that the GDI has been extended for the web application as well as and also for the Windows applications, and that provides more components to be drawn on the form. So system.drawing is a namespace or a libraries which has numerous types of the basic renderings such as the fonts, pens, basics brushes, etc. So all the fonts and the pens and certain basics brushes can be drawn using system.drawing. As its name indicates, the drawing, which means that we can draw certain object or certain shape using the pens and the basic brushes. But we can change their fonts and color as well. So these are the almighty graphics types. So we will use the graphics class to draw these different components onto the form. The second important library is system.drawing.drawing2D. Now this is the extension of the first library because you can see that drawing 2D is inherited from the drawing class and drawing class is inherited from the system class. So here you can draw the 2D shapes as well. So this namespace provides the use for more advanced two-dimensionals are the vectors graphics functionalities. For example, gradient brushes, pens, caps, and geometrical transformation. Now you can see that the pens caps is in the 2D. So we have two dimensions of the pens cap. For example, when we write some things using the pen, if it is a small pen, then it has a direct straight lines writing. And if it is certain pens where we can write certain another language writing like Arabic writing or Urdu writing, then we can use different pens here, and then that pen will be 2D pen. So we can use the two-dimensional uh, pens and their caps for the drawings. Also, we can perform the geometrical transformations. Geometrical transformation means that when we want to rotate or transpose the image, then we will perform the geometrical transformations. For example, we want to rotate the image to the 90 degrees or to the 40 degrees or 45 degrees, then we will use this namespace classes. The another namespace is system.drawing.imaging. As clearly its name indicates, this namespace is used for drawing the images onto the surface of the form. So this library allows you to manipulate the graphical images, for example, changing the palette or extra image metadata or manipulating the meta files, etc. So we can draw the images using this library. Next important library is system.drawing.printing. This library performs the printing. It in fact prints the page that you want or print the form that you requires to print. So this is very much important library when you want to print the page of a website or you want to interact with the printer itself or you want to format the page or that jobs that are sent to the printer, then you will use system.drawing.printing library. The next important library is system.drawing.text library. This library allows you to manipulate collection of fonts. and the fonts is in fact related with the text. So we can change the font of the text using system.drawing.text, and also we can draw different text as well. Now it is very much important to understand the functions of the GDI. The functions are different methods which in fact is used to draw different components of the graphical objects onto the form. The first method is the draw arc method. The draw arc method is from us used to draw the arc. So the draw arc method draws an arc from a specific ellipse. The ellipse will be in fact a circular system or a circular object, and that one part of the ellipse is called the arc. The next is the draw Bezier. The draw Bezier draws a cubic Bezier curve. The cubic Beziers will be certain Bezier in which it will be in the form of the cube or the cuboid. Draw Bezier's function. The draw Bezier function draw a series of cubic Bezier curves. So there will be multiple Beziers in draw Bezier functions. Draw closed curve. The draw closed curves draws the multiple curves, and all curves will be closed. So here the draw closed curve functions used an arrays of different points to draw the closed curves. And the first point and the last point will be joined with each other. Draw curve. The draw curve function draws the curve which is the collection of multiple arrays of the points. And the points are in fact the multiples elements of the arrays, and the draw curve function processes that arrays and then draw the curve. Draw ellipse. Draw ellipse function simply draw the ellipse. Draw image. The draw image function is used to draw the image. The image will be a certain files on your hard disk, or it can also be taken from the online resources. Draw line function. The draw line function draws the lines between two different points. Draw path function. The draw path function draws the lines and the curves which is defined by the graphics path. So here you can draw multiple lines using the draw path function. Draw pie function. The draw pie function draws the outline of the pie section. And the pie section will in fact be used to represent the numerical data. Draw polygon. The draw polygon function is used to draw the polygon. The draw the polygon will be the outline of the polygon. Draw rectangle. As its name indicates, this function will draw the rectangle, and the rectangle will be the outlines of multiple points. So here different lines will be drawn here, and the lines will create the rectangle. Draw string function. The draw string function will draw the strings, and the strings will be drawn on a specified points on the form. Draw ellipse. The draw ellipse function, the fill ellipse function will draw the filled ellipse with a particular curves. So the filled ellipse will be the interior of an ellipse defined by the bounding rectangles. Fill path. Fill path function will fill the interior of a path. That means that the path will be filled with a certain color. Fill pie. The fill pie function will fill the pie with a specific color or a texture. Fill polygon. The fill polygon function will fill the interior of the polygon defined by the arrays of multiple points. Fill rectangle. The fill rectangle function will draw the interior of a rectangle with a certain brush here. The brush has a certain color as well. Fill rectangles. Fill rectangles function will draw the rectangles with a certain brush. Fill the region. Fill region function will fill the interior of the region. So the region will be filled with a certain color or with the help of a certain brush. The point f type is a special function that is inherited in the using system.drawings.point class. And the point class is inherited from the drawing class. In the GDI plus, which is the extension of the GDI, the point f class or functions supports a number of helpful members. Here, the members includes additions, that means that 2 points can be added. Subtraction, it means that 1 point can be subtracted from the second. Or comparisons, that is 1 point is equal to the second point. Are not equal, that means that 1 point is not equal to the second point. So here we will overload the point functions with various C# operators, and these are different operators where we can overload the operators of the point function with a C#. And xy will be the two coordinates of the points. For example, this is the screens here. This is x-axis coordinates and this is the y-axis coordinates. So x-axis coordinates is here from the left to right and y-axis coordinate will be from the top to bottom. So these coordinates provide access to the underlying xy values of the point. And also the point functions as a member is called is empty. This member returns true if x and y are both set to 0. For example, if a certain point has the coordinates 0 and 0, so it will be lie here on the corner of the top, that is the left top corner of the window. So that will be set to either 0 and 0. Now here we will demonstrate the example of strings drawings in the GDI. The most common way to draw a strings or any other objects on a graphics object is to interact with the paint event. So here we will create the paint event and then using that paint event we will draw the graphics. So for this purpose you require the Windows applications here. You can see this is a certain Windows applications. Hello GDI plus is the strings that will be plotted here or it can be drawn here. So first we have an important library using system.drawing and using system.text here. This library is already included on the form because when you drag drop a label on the form, then these two libraries are used there. Then we have the namespace Windows Forms application 10, which represents the project names. Then we have public partial class form 1. Form 1 is our class and it is inherited from the form. And the form is in fact implemented here in this library using system.windows.form. And this is the constructors. So we have not to do any coding here and just we need to override the onPrint function here. The override onPrint function will be in fact coded from the programmer sides. This is the protected override void onPrint. Protected means that it is only accessible to the childs, but it cannot be accessible outside of the class. So that's why there is the protected, because you can see that form 1 is inherited from the form. So protected function is overridden here and onPrint function is overridden here. Overridden means that we have changed the functionalities here. So we are using certain built-in function on point and we are overriding it with this code. Paint event ERGSE, it represents the data of the event. Next, we will in fact override the onPaint function. So that's why we have again called the base.onPaintE. So it also calls the base class implementation. The base is the parent class. So we will call the parent class function onPaint here first. Then we will perform our own coding. first we need to create the graphics objects. G is equal to E dot graphics. E dot graphics mean that it is in fact implemented in the graphics class, and E represent the data of the onPrint function. So all the data will be assigned to the G. So that's why we have an instantiated G. It is not like the common instantiation objects like graphics. G is equal to new graphics, but here it is in fact taken from the built-in class graphics. So that's why we have just called that function class here e.graphics. Then we have GDrawStrings. GDrawString is a function which draw the strings, and hello GDI is the strings here. Hello GDI plus is the string here which will be drawn here. Comma new font Time New Roman. Time New Roman is the font name, and then 20 is the font size. So it will print the Time New Roman font here with the 20 size. Then comma brush.green means it will be printed with the green brush, and x-axis y-axis is both 0. That means the printing will be starts here on the top left corner of the window, which has the 0 x-axis and 0 y-axis coordinates. If you increase these two coordinates, you will see that this drawing will be shifted to the another position on the form. Now, dear students, we will implement this code. For this purpose, click on the escape button of your window. Next, we need to start the Visual Studio. So, just start the Visual Studio from here. Then you will required to take the Windows applications, because the drawing is will be performed on the Windows form. Let's create a new project. You can create new projects from here, or you can also perform this coding on the existing project of your Windows application. So I clicked on the new projects, create a new project here. Next we will take the Windows application. So change the language here, C sharp. Then you have to scroll down. When you will scroll down, you will find the Windows application. This is the Windows application. Click next. After clicking next, you need to provide the name of the projects here. So, for example, this is our names by default Windows Form application level. I will write that GDI example. This is the name of the project. Create on the click on the create button. Meanwhile, the Visual Studio will create an empty form for you, where we will perform the GDI programming here. Now you can see that an empty form has been created. This is an empty form here. You do not need to draw anything from the toolbox here. First of all, on this form from the toolbox. So just don't draw anything on this form from the toolbox. Now we can see that in the slide there is the protected override void on print functions. So you have to just transfer these functions, and you need to implement this function immediately after the constructor. Now right click here, view, click on the view code here. Already I have transferred this files this code here. So this is the onPrint function. That is, you should write this code immediately after the constructor of the form, that is public form 1 here. So this code will in fact print the hello GDI on the form. So to run the applications, click on the start buttons here. I clicked on the start buttons. Now here is the output, and the string is starting from the top 00 coordinates of the form. That is the top left sides of the forms. If you change this coordinates, for example, I want this text 20 and 50, that is x-axis 20 and 50 on the, that will be the in fact the 20 and 50 on the forms here. So just click here and run the application. Now you can see this is 20 this position and 50 downwards. So this edge of the H well starts from the 2050 position on the form. So this was the applications that we have developed. Now we will resume our slides for the next topics. The next topic is obtaining the graphic objects outside of the print event handler. So we have just seen in the previous example that the graphics objects, that is graphics G, which is inherited from e.graphics class, it was in the print function, but now we were accessing that's outside of the print event handler. So in some cases, we requires that we need the graphics objects outside of the scope of the print event handlers here. For examples that we want that to draw a small circles at x and y positions. X, y may be the coordinate systems of the drawing. Where the mouse is clicked. So when we will click the mouse, then the drawing will be performed on that particular xy coordinates, and the xy coordinate will be taken at run times where the mouse click will occurs. So then we will in fact implement the mouse down event handlers here to call the static graphics from HWN functions here. So we will use that a static graphics dot from HWND functions here to in fact monitor that where the mouse has been down. So this is the examples here. That is the form underscore mouse down event. We will implement that example as well. Then we have the graphics G, graphics dot from HWND. This dot handles means that where the mouse has been downed. So then that object will be created by the graphics G, and the G contains that where is the position of the mouse, and it will then draw the graphics here. Now G dot fill ellipse, this is, you can see this is the fill ellipse with a particular color. G dot fill ellipse brush dot fire breaks. Here the fire break color has been used, which is, you can see that that is the little bit reddish colors, but it is the fire break colors. E dot x is in fact meaning that it will take first point, that is x and y, and this is the second point. So from the first point and second point, the mouse will print the filled ellipse, and the first point will be taken as like the coordinates of the mouse. So the coordinates of the mouse will be e dot x comma e dot y. Now what is the e? E is here an object which is sending the event, and it is the mouse object. So from underscore mouse down object, E represent and y, E x and E y represent two coordinates, that is x and y coordinates, where the mouse will be down, and 10 and 10 represent the size of the this filled ellipse. Then we have G dot dispose. G dot dispose will dispose all the graphics objects that we have created here. So here the important function is G dot fill ellipse. So it will draw 10 by 10 circle where the mouse has been clicked here. Now we will implement this example in the previous example. So click on the escape button. So here I have just escaped that. Now this is the code here. Go to the Visual Studio, click on Designs Forms, right click here, go to the Properties and click here, so that you will see all the events of the form. So now search the mouse down event. So mouse down event is here. So this is the mouse down event. Double click here to create the mouse down here. So I have double click here the mouse down event. Now transfer this code from the slides to the mouse down event in the form. So I transferred that here. Now run the application from start green button. So this is the our examples. Now where I will click on this form, the red LFC, that is the LFC with the brush cut fire bricks will be printed, and that will be of the size 10 by 10. So this you can see here, the mouse is printing a certain filled LFC with the fire bricks color. So this is the filled LFC, and where the mouse is downing, then the filled LFC is printing here. That is the filled LFC where that particular mouse is down here. Now we will resume our slides. Next are the GDI coordinate systems. GDI has three different coordinate systems, and it is used by the runtime to determine the location and size of the contents to be rendered. As in the previous examples, when the mouse was down on that particular locations, it takes the location and the size. So I will go here. This first point is the location, and this second point takes the size. Second point is constant 10 comma 10. So that means that 10 pixels x-axis and 10 pixel y-axis, the size of the field ellipse will be drawn here using this coordinates positions e comma x, e comma y. Okay, so that represents the coordinate systems. Now we have three different coordinate systems. First one is called the world coordinate system. The world coordinate system is the abstracts of the size of a given GDI types. And the examples is this one, that the world coordinates represent to draw a rectangles with the dimension 0, 0, 100, 100. So first point is 0, 0, that is the start of the screen, and 100, 100, 100 x-axis, 100 y-axis. For example, this point will be 100, 100. So from here to up to here, the rectangle will be plotted here. The next coordinate is the page coordinates. It represents the offset applied to the original world coordinates. So the page coordinate represents the particular offsets that is applied over the world coordinates. And the third one is the device coordinates that represent the page coordinates to the original world coordinates. And this coordinate system is used to determine exactly where the GDI plus tab will be rendered here. So device coordinates mean that, for example, if here we provide another points values, then the device coordinates will print that particular object at that particular positions, and also with the help of this size, that is 100, 100. Now here is the examples of the coordinate systems. First we have overridden here the on-paint function private event argse. Students, remember that this event cannot be created from the properties dialogs. You just need to type this code directly, because onPrint function is automatically implemented in the initialized components here. Now in the body of the onPrint we have graphics ge.graphics. Graphics G represents the object of the graphics, and the object is instantiated through the graphics class here. And the graphics class is implemented using the system.drawing library. Then we have g.drawRectangle. G.drawRectangle will draw the rectangle here. And then we have pins.blacks, means that the black pins rectangle will be printed. And the first coordinates of this rectangle will start from 10, 10, which is the first point, and the last coordinates of this rectangle will start here for up to 100, 100, which is the second, in fact, the second corner of this rectangle. So when we will draw here, so we will click here, and then that will be drawn here. So you can see that it will be drawn here from clicking here up to here. So that's why this coordinate system will draw the particular value here. Okay, so we will, in fact, also we can implement this code. To implement this code, click on the exit button. Now, in our previous examples, we have already on print functions which has been added here. So you can just write one line of code, that is this one, GDI draw rectangles from here to here, and just transfer this code from there up to here. Now just run the examples, then you will see the rectangles on the surface of the form here. Here, just click this green buttons to compile and run the application. Now this is the rectangle which has been drawn here. And also the other forms, the other example is working here, which draws the filled ellipse on the form of surface. Now we will resume our slides for the next examples. Next one is the example to translate transforms. This is the function which transform the objects, and it will take two parameters x-axis and y-axis, that is two integer values 70 comma 10. So 17 x-axis and 10 y-axis, that means 70 starts from here up to here and 10 starts from here to there. So this is the starting point of the rectangle. So it starts the rectangle from this starting point. Now this point will be ignored here. So initially in the previous examples, this first point was 10 10, while here it is still 10 10, but the rectangle has been transformed. Transformed means it is shifted to another positions, that is 70 comma 10 here, and that black rectangle has been printed here. Dear students, this is the end of the lectures. Hope that you have got informations from these lections, and if you have still any point, you can read this book. The book is very much useful for you. The book is the Practical C# Charts and Graphics, second editions, Advanced Chart and Graphics Programming for Real World .NET Application, and it is written by the Jexu PhD. So it is very much important books where you can use or you can draw different charts, and these charts will be act as a building blocks for gaming applications. And also if you have any questions, you can ask the question through the email. My email is m.kadeem@kust.edu.pk. I will wait for your question and will respond to you immediately as soon as I will get them. So thank you very much.